Huge, resolute, brilliant. The sun we think we know. It provides the most romantic settings, the most restful vacations, the subject of our earliest imagination.
People think of the sun as a simple yellow ball.
It's pretty quiet and rises and sets and really doesn't do a whole lot.
A source of warmth, a source of light, and a source of happiness.
It is so common, we don't look at it, and so powerful, we can't.
It's somehow ruling our bodies. It rules all the other animals. It rules everything else that happens on the planet.
Ancient people knew to align themselves with the power of the sun. They built Stonehenge, Tikal, and Machu Picchu with great devotion.
They were the ones who made the world go round, or the sun go round.
Today's solar scientists certainly have their own specialized tools to look at the source of our warmth, the source of our food, our energy, our light. Yet for all of us, the sun's power and mystery remain.
We forget that it rules us as well.
Have you ever considered balloonists to be creatures of the dawn? They often are. Flying their craft in that calm window of time that exists after first light, but before the sun has heated the land enough to create a breezy, bumpy flight. In Guilin, China, the light appears each day for people in the city park. With these movements, they greet its warmth, much like their ancestors did 8 centuries ago. These are merely 2 of the million small fingers of the sun that reach into the landscapes of our lives. We are profoundly dependent upon its heat and light. It's impossible to imagine a tomorrow without the sun. In the past, the strange, brief absence of the sun during an eclipse was deeply unsettling for ancient people. To this day, we view an eclipse with wonder and a tinge of fear. What are some of the small secrets of the sun? For animals, for the ancient people who built the great celestial structures, for today's solar scientists, if we look at the details, we will see an extraordinary star in this ordinary sun. This temple, called Wat's Fei. The coming sun triggers the morning meditation for monks. The light welcomes the arrival of children at the compound gate to start the school day. Wherever you look, you'll see the morning sun engaging the life Daily cycles, the sun determines seasonal patterns for life on the planet by setting water and ground temperatures, cloud and surface cover, and the lengths of day and night. Migration, like these alewives, waiting for warmer waters off New England. Or hibernation, like these recently awakened brown bears of Alaska's Katmai coast. Halfway between the South Pole and the equator, we see other small secrets of the sun. In the largest colony of Magellanic penguins in the world. To get here, birds must sense the increasing sunlight of spring and then migrate 1,000 miles or more. The purpose? Spring cleaning, nesting, and the launch of a new generation. Once they're settled ashore, they face a second challenge triggered by the sun: excessive heat for their already warm bodies.
The major problem that these Magellanic penguins have, because we think of penguins, of course, as found very deep in the south, but this is not very far south. This is a temperate species of penguins. Here, the problem for penguins is heat. And so what they do to be able to stay cool is they end up losing the feathers around their bill, so that exposes the bare skin on their face. And if it's hot, just like a runner gets a red face, a penguin will get a red face. What they're doing is shoving all the blood into the exposed skin and losing the heat that way. They also lose heat off their feet, and then of course by putting out their flippers.
For penguins here, the sun's heat has a major effect on body temperature. Elsewhere, the sun plays a role in the survival of a species. 1,000 miles north, deep in the Amazon rainforests of eastern Peru, we see other little-known responses to the sun's heat and light. An hour or so after sunrise, something unusual happens along the shores of the Madre de Dios River, in areas where exposed clay deposits are softened by the morning heat. Hundreds of colorful birds collect here, like dusky-headed parakeets and cobalt-winged parakeets.
Parrots, parakeets, macaws, and parrotlets, they all eat the clay to protect themselves because they are seed predators. Before they go to eat somewhere in the forest, they need the clay.
Each morning, the birds have two goals, both dependent on the sun. The first is to eat some warmed clay from this bank, called a kulpa, or clay lick. The clay contains minerals that protect these birds' stomachs from the toxicities of the seeds they will be eating for the rest of the day. The second goal, particularly during September and October, is courtship. Male birds need to attract mates. To do so, they flash brilliantly colored underfeathers in the light of the sun. For food, shelter, energy, and order, all of Earth's creatures depend upon the sun, including us. Before fire and electric lights, we spent 1 million years cowering in the cold darkness, hoping for the sun to come back each morning.
We've been living on this planet a whole lot longer than we've been thinking about the planet, and there are things ingrained in us, and they're based on where's the sun, When's it coming up? When's it going down? When's it going to be warm? When's it going to be cool?
The sun certainly provides some of nature's best special effects. Collected in the book, The Sun.
The idea behind the book was to sort of tease out the different colors of light, the different ways that it impinges on and affects and drives life.
And we were just astounded. And once we started looking for the solar effects, yeah, rainbows, yes.
You get sun pillars. If you look at a sunrise or sunset, you'll see sort of a pillar of light stretching out of the bottom of the sun, the top of the sun. What it is that it's light bouncing off of the crystals of ice in the atmosphere.
Something called a Brocken specter, which is like your own shadow looking down from a peak, and then you see this arc around you. I didn't even know it existed.
More complex and mysterious, found in the cold skies of the extreme northern and southern hemispheres, is a polar light show that once witnessed is never forgotten. The aurora.
The sun set, where'd the sun go? The day's over, but an aurora is an expression of the sun's energy in our atmosphere at night.
We live in the sun's atmosphere. When the sun streams out particles, they excite molecules here, releasing light. Auroras have painted our skies since the earth began. The Vikings imagined they were a bridge to the gods. Others felt they predicted great feasts or great famines. They are another example of the sun's reach, occasionally providing light to the darkest night, relentlessly providing warmth to the coldest day. The sun's powerful force inspires awe, fear, and devotion. People of the past ritualized these emotions and responses, aligning themselves with the sun more than we do today. We have much to learn from studying their life with their star. Stonehenge was built over thousands of years, a monumental prehistoric stone circle on the chalk plain of Salisbury, England.
There's a marvelous alignment at Stonehenge, well known since the time of Stukely in the 18th century. And that is that the axis of Stonehenge, the axis of that horseshoe-shaped trilithons, which were built around 2750 BC, that alignment goes through goes over a heel stone, which is a large megalith, now tilted, and it points to the place where the sun rises on what we would call the first day of summer, what the modern Brits call midsummer's day.
Many have searched among the stones for other alignments, with the moon and other celestial events. Theories have been suggested, but the old rocks will not give up their stories. And we've only clues about the people who came to this plain, first to move the rocks, then to move among them.
Stonehenge goes back to about 3000 BC, probably started by a group of maybe 7 or 8 or 10 extended families of about 150 people apiece. These were nomadic, largely nomadic people. We're talking about Bronze Age Britain, long time ago, pre-literate, no written history. 2750 BC, some wise guy gets the idea to make this thing in stone, and that's really what's marvelous about Stonehenge. It's the different kinds of stone that went into its building. It was a monument for all time. I think it probably was a true believer who was the workforce here. They would have worked all their lives, their kids would have worked all their lives, and their kids would have worked all their lives. It was about the process of building, not about the finished product done on time, on budget, which is us. And they're not us.
What was important about the building process nearly 5,000 years ago? What did the true believers of Stonehenge believe in?
We know that in the beginning it did have that axis and that causeway pointing directly to the solstice sun. So there must have been some fundamental sun worshiping going on.
Because the stones draw the curious eye and so many questions, they've provoked the most thought. Less known is the evidence that the causeway, a 2-mile-long path leading down to the river Avon, was heavily used.
This really suggests to us that Stonehenge is all about assembly. It's all about people parading up that grand highway or causeway to go into the center of the enclosure. And what did they do there? They had a market. They had a place of worship. They probably held worship services to their gods, who were undoubtedly the sun and the moon, to judge by the alignments. And they interacted, they socialized, they bonded themselves together as a society, and then they went off to do their farming and other things that they had to do. Now, there's strong evidence that a lot of this bonding in this inner circle or inner sanctum of the great Stonehenge took place around the June solstice. And on that date, the sun makes its appearance. What a fabulous time to have Stonehenge bathed in the morning light as people walk up that causeway, their long shadows being cast into the center. And of course, if I were the ruler, I'd be the first guy in the parade, and my shadow would enter that inner sanctum first.
The society that placed these stones, once nomads, were increasingly farmers. Aware of the summer solstice, the longest day of the year. That's the time the sun here reaches its maximum northerly position. Trees bear fruit, animals are fat. It's a time of prosperity. High in the Andes of Peru, secrets of the sun are revealed in the 16th century Inca royal sanctuary of Machu Picchu.
Fantastic, the colors, the shadows, the whole place becomes alive, and you you actually are filling yourself with this golden light because the color is very important. It's very warm, and I've seen many people opening their arms and welcoming the sun.
The Incas believed the world was the work of a creator who rose out of Lake Titicaca. As he headed north, he formed these mountains before entering the Pacific Ocean. He promised to send a daily reminder of creation.
The Incas believed that it was the sunlight, not the sun itself, as an aster, but the light that the sun generated that was divine. And it was that light what created life on the earth. They were not too far away from what reality is. So the divine was manifested through the sunlight, and that was impersonated in one called Inca. This Inca, as when you are God, it's very difficult to delegate. The Inca had to create a system to multiply his presence all over the empire. And to do so, he constructed places, he constructed observatoriums, he constructed places where the ritual observation of sunlight will happen twice a year.
One observation happened at the summer solstice. The winter solstice, the shortest day of the year, was marked here in Machu Picchu at this structure, the Torreon, or the Temple of the Sun.
Now that's a really interesting event when the sun reaches the solstice. It's the time of year that's equivalent to our Christmas. Our Christmas comes from a pagan Roman festival, the Day of the Unconquerable Sun, Dies Solis Invicti. And that's the day when the sun is threatening us with leaving our world, with going to the farthest to the south. And I imagine the ancestors of the Inca would have been very anxious when that sun began to go away. But the idea of bringing the sun back on that day, very important. And it's why, incidentally, we celebrate Christmas on that day, because when the Christians took over the pagan festival, they thought, well, this is the time to bring the light of Christ into the world.
Winter solstice time, that was marked on the skyline. If you look over in the mountains, there is a V out there. And through that V, the sunlight will come exactly into the window that's down below in the Temple of the Sun, marking that rock that's laying down there with a perfect shape of the trapezoidal window projected into the rock.
And some astronomers who've studied Machu Picchu think that it's possible that there was a wooden device that was put on that window with a wire or a string on it, which would be such that the shadow of that string on the solstice sunrise would go right down that beveled edge, which in fact it would.
1,000 years earlier than the Inca, and farther north, a culture arose in the tropical jungle with its own secrets of the sun. Between 200 and 800 AD, the Mayan civilization blossomed across Central America.
Well, of course, if you look at the environment around Tikal, it's a jungle. It's a typical rainforest, 3 layers of growth. Howler monkeys, all sorts of snakes and lizards, the kind of environment you wouldn't find in Cincinnati. The Maya were very closely tied to this environment, and everything they saw had meaning, and the meaning was always cast in symbols. For example, did you know that in the previous creation, the gods created monkeys? And it was monkeys who were the dominant population. We still see the remains of some of their ancestors climbing around trees, for they once ruled the world.
The Maya were a highly literate culture. At their peak, they amassed libraries, wrote sophisticated calendars, and recorded events on upright stone tablets called stelae. Skilled astronomers and mathematicians could make 1,000-year predictions of the exact movements of the sun and other celestial bodies. And the Maya were superb builders.
Well, if you take a vantage point in Tikal, such as the Lost World complex, you'll have a view of the ancient skyscrapers of Tikal. Temple 4, the tallest of them all, 230 feet high, hasn't been excavated yet. Then, off to your right, you'll see Temple 1 and 2, almost as if they're dialoguing with each other, perfectly aligned with the equinox, the rising and setting points of the sun on the first day of spring and the first day of autumn.
The buildings in this great Guatemalan city of 150,000 were all carefully planned and constructed by a succession of kings, a dynasty that lasted almost 7 centuries. Control of time was a particular obsession for these Mayan kings, who had one word, keen, that meant both day and sun.
The Maya reasoned that the sun controls the seasons. There's no question about that. When the sun is here, when it's high in the sky, there are these plants and animals. When it's low in the sky, there are those plants and animals. I'm not talking cause and effect here. I'm talking about an associative relationship. You associate the position of the sun with the behavior of things on Earth. Now, to track the movement of the sun in Tikal, they had a really interesting instrument. It was an instrument consisting of an architectural assemblage called the Lost World assemblage. And it consists of a radial pyramid on the west side of an open plaza. And on the east side are 3 structures, one on the north, one in the middle, one in the south.
The sun would rise behind one of these 3 structures, indicating the longest day of the year, the shortest day of the year, or the equinox. The Maya brought celestial observation into every aspect of their life and every hour, not just to keep track of time on the longest and shortest days. These people believed the sun and moon spoke to them. Their astronomy was paired with astrology. They took cues from the heavens to guide every step of their life. Gathering under these temples in great plazas, including the open space recently called by some the Lost World Observatory.
And I think we really have to start to rethink this word observatory. Now, when we think of the word observatory, what comes to mind? Scientists, white coats or not, very precisely working on predicting with unerring accuracy where something is going to take place. I think that the observatories of the Maya were more like planetaria. It's a theater. It's a place where you go to witness events that take place in the cosmos. The job of the astronomer is to set up that specialized architecture so that the sun may be delivered to the appropriate place at the correct time, so that the sun can be worshipped. And I can well imagine the worshippers goo-gawing at the sun when it came over that tower at exactly the right time. And that's the work of astronomers. That's what an observatory is. It's not so much about precision and collecting data as it is about creating a theatrical spectacle. Astronomy is theater.
Today, from various vantage points on the planet's surface, solar scientists participate in their own way with their own set of tools. Ground-based studies of the sun are often interrupted by bad weather, by night, and by the optical interference of dust and particles in the Earth's atmosphere. To avoid this, in 1996, scientists successfully reached a clear vantage point in space.
There's a very key location that is about 1 million miles away from the Earth. We call it the L1 point, and it's the point where the gravity of the sun and the gravity of the Earth actually balance. So if you put a satellite there, it will stay in orbit around that point.
The sun's 93 million miles away, so L1 is about 1% of the way to the sun.
So it's always pointing at the sun 24/7, so you get uninterrupted data for a very long time.
The new view of the sun we've always known requires leaving Earth, but leaving Earth makes all the difference. Activities of the sun are now recorded by satellites, such as the one called SOHO, for Solar and Heliospheric Observatory, modeled at SOHO Command Central in Greenbelt, Maryland, with a 1/10 scaled replica.
Well, SOHO is a major mission that was developed in conjunction with the European Space Agency.
And it was a European idea, but the Europeans realized pretty quickly that it was getting too expensive to build it just by themselves. So they teamed up with NASA.
SOHO holds 12 instruments, each offering access to our star's secrets: ultraviolet, X-ray, and magnetogram, to name a few. More instruments on newer satellites like TRACE, STEREO, and SDO will further reveal secrets of the sun. Along with SOHO, they'll use different spectrums of light to measure the sun's atmosphere, otherwise known as the corona. At the sun's surface, a white light measurement reveals 6,000 degrees Kelvin. Moving further from the surface, UV light measures 60,000 degrees in the lower corona. And even further away, in the mid-corona, it's 1 million degrees. Strangely, the sun's atmosphere gets hotter as we move away from the surface, riding the solar winds of the corona.
One of the big mysteries, I think, for solar scientists is just why the solar wind is there, why this outer layer, the corona, is hotter than the solar surface. We take pictures of the sun. The sun is so bright that if you just take a picture of the sun, you won't see the corona around it. So we create artificial eclipses. We put a disk that blocks out the light of the sun, and our cameras are able to see this lovely hazy atmosphere continually streaming away.
That's the little armature that holds that disc in place, right?
Exactly, yeah. That's just a little metal boom that keeps this little metal disc in place as like a thumb on the sun. And the white circle indicates how big the sun actually would be.
The particles that loop and stream from the sun's corona are created by powerful magnetic forces. These tangles erupt into massive ejections.
The rotation on the sun is not constant at the poles and at the equator. The equator actually spins slightly faster than the poles. So it's hard to visualize, but if you think of taking a piece of string and you're pulling the center, that's going a little bit faster than the outside. The sun's magnetic field rotates with the sun. So if you start pulling that middle bit just a bit quicker than the outer bits, it starts to get very confused fairly quickly. The middle is no longer a nice uniform, it's stretching and twisting. And as it becomes more and more confused, little loops of this magnetic material pop up above the surface of the sun. You can see these on several of the beautiful images. These loops, now you've got something sticking up. It's not in its happy configuration, and it's very easy for that to then be ejected away as a coronal mass ejection.
You see this stored up energy, you see this evolution, you see these magnetic loops always evolving, and you can really get an idea of the power of that eruption. You realize the size of that eruption compared to the size of the Earth. And these eruptions are just thousands of times larger.
When you have an eruption on the sun, then you get like this huge cloud of plasma moving towards a certain direction, for example, the Earth, and it impinges upon the Earth's atmosphere and generates strong currents and electric fields in the high layers of our atmosphere.
And the most beautiful thing that you see is it will power very intense aurora. Watching that star on the web. We have our cameras that are out there 24/7, beaming the pictures back all the time to us.
Yet it's clear that today's relationship to the sun via satellite is quite different from that of past cultures, when a directly observed sunrise meant the difference between feast and famine, strength and weakness.
We have these science images, these beautiful views of the sun all the time, 24/7, and yet when I get up in the morning, let's say, and see a sunrise, I don't really think of it in terms of those other kinds of imagery. So there is a bit of a disconnect sometimes.
I think even when you're on vacation, you can be lying on the beach and looking up at the sun and thinking, I hope it doesn't do anything really exciting while I'm away because I'd hate to miss it.
So the irony, the wonderful irony, is this deep knowledge of very esoteric knowledge about the sun, all very valuable and useful, but the most direct knowledge of it, when it rises, where it sets, what time it is, what represents it, is almost totally absent.
On this morning, viewable from this Brazilian beach, a rare and special event is about to begin. A total solar eclipse. Shortly after sunrise, here, the moon will move into direct alignment between the sun and the Earth. For a few lucky people on this day, the moon will completely block the sun and cast its own shadow on Earth's surface. The shadow will travel from here across the Atlantic, over Africa, Turkey, and Asia at a speed of at least 1,000 miles an hour, before ending at sunset in Mongolia.
I have never seen a total solar eclipse.
I'd love to see an eclipse.
I'm always in the wrong place. When I lived my whole life in England, never a solar eclipse.
I've made a poster about eclipses and written about them.
I moved to America, and the first year I'm away, there's a solar eclipse visible from England.
I will see one before I die.
Something very ancient and primitive about viewing an eclipse, and at the same time, something extremely scientific.
An eclipse is an excellent opportunity to study the outer atmosphere of the sun. The moon is an entire planetary body, and it blocks out the sun's photospheric light better than anything that we've been able to design thus far.
It's one of those places where science and sort of spiritual, visceral human life comes together.
The moon, the new moon, and the solar disk. And it's kind of fun to look, seeing how closely you can predict that. Who's going to see that first bite? Is it going to be on time? And then there's that long period, about an hour and a half, where you get partiality and the bigger and bigger bite. And then as you get closer to totality, the sharp shadows that come from the sun, which now acts more like a point object. It's a slit. And we're so used to illumination by a disk, which gives you diffuse shadows. And now the shadows get sharp. The light gets pale. There's a brownish color. The air gets still because the temperature drops. And then it really is literally like taking a quilt or a comforter and pulling it over your head. It gets dark. And it happens that fast. And it's in that moment, that few seconds when that shadow is just about over you, that if you turn your eye to the sun, you'll get that glimmer of sunlight coming down a valley between a couple of mountains on the moon. That 2 or 3 second experience of that flash of light, followed by the consequent disappearance and darkness. Those 5 seconds are the most exciting moment for me, and I think probably for most eclipse watchers. I will never forget, a woman standing next to me was crying, tears flowing down her face, and she said it was a miracle. It was a miracle. She was so taken with darkness in the daytime, with the rushing shadow of totality coming like a blanket over the earth, with the stars and the planets bursting out into the environment, and the strange feeling from the behavior of nature. She was overcome by that, and so were other people. That's what an eclipse is, and I don't think it was any different for ancient Stonehengers when they saw it.
When we take the time to notice them, the simplest and most common of experiences can be the most miraculous. Each morning, the man who first pointed his telescope toward the sun described our star well. The sun, with all the planets revolving around it and depending on it, can still ripen a bunch of grapes as though it had nothing else in the universe to do.